Hey guys, welcome to the video on potential and kinetic energy. I have three goals for this lesson. The first one is I want you to describe, kinetic and potential energy. Number two, I want you to solve problems involving potential and kinetic energy. And number three, I want you to explain what these two ideas are and what they actually mean. The first part is kinetic energy. This is the energy of a mass that is in motion. So an example of kinetic energy would be like a cat running across the floor or a car driving to school. And the formula for this is kinetic energy is equal to 1/2 the mass times the speed squared. And oftentimes you will see this in terms of this equation right here. And the SI unit for this is the joule. And as you probably are aware, the joule is the same one as work. So kinetic energy and work share the exact same unit. So let's go ahead and look at a quick sample problem here. A student throws a pie at Mr. Russell, and the pie has a mass of 1 kilogram and is moving at a velocity of 3 meters per second squared. Squared would be acceleration. This here is just velocity. Well, the equation basically said that it is going to be the mass times the velocity squared divided by 2. So your answer here ends up being basically 1 times 3 squared divided by 2, and you get 4.5 joules. So this pie doesn't have a lot of energy behind it. So what about work and kinetic energy? Well, work is the change in kinetic energy. So work equals just change in kinetic energy. This is called the work kinetic energy theorem, and it's an idea that will show you the relationship between kinetic energy and work and sort of how the two are related. And the formula for this will be shown here, which is that the net work is just your change in kinetic energy. Now the next idea is an idea called potential energy. Potential energy is the energy of an object that has potential to move. So an example for this might be a rock that is hanging over a cliff, and if the rock is pushed, the potential energy becomes kinetic. This is another idea of gravitational potential energy. This is the potential energy created by gravity, and it follows the formula potential energy, and the small g here stands for gravity, is equal to mass times gravity times height. And this gives you how much potential energy is involved here. And the SI unit for this is also going to be the joule. So they are very, very similar in how they operate. And basically, potential energy is just another way to measure energy, like kinetic energy and work. So here's another sample problem. Mr. Russell is standing next to a cliff looking down at a flower. An evil student sneaks up behind Mr. Russell and pushes him off the cliff. Mr. Russell has a mass of 95 kilograms, and the cliff is 15 meters high. What is my potential energy going to be here? Now, basically, I weigh 95 kilograms, and gravity is 9.81. And the height is 15, so it's 95 times 9.81 times 15, which gives you the answer of 14 kilojoules. Now, this is actually just 14,000 joules, but because it's a kilojoule, you know how a metric system works, you can shorten it down. So 14 kilojoules is how much potential energy I have. Now there is one last idea here, which is called elastic potential energy. And this is the energy that's created with a spring or like a rubber band, something that has elasticity. Now elasticity is something like a spring or a rubber band where you can pull it and it's going to store energy, and you let go, it's going to snap. Rubber bands are great examples, and so are springs. Now, this is basically a way to tell you how much energy is stored inside of the spring. And like I said, examples are going to be like rubber bands, cords, ropes, and things like that. And the formula for this is going to be 1/2 the k times the x squared. Now, what do these actually mean? Well, the 1/2 is just, 1/2. The k is a spring constant. This is something you're either going to be given or it's something you're going to have to calculate when you know the other information. Think of the spring constant kind of like mu from friction. It's just something that's been calculated before, and it gives you a rough idea about how much energy that something can store. The last one, the x, is just the distance that it's compressed or stretched. So this is how much it is being compressed or stretched squared. And like I said before, the spring constant is just a measure of how many newtons per meter a spring can store. And usually this is given to you in the problem, but some advanced problems might have you calculate it. So here's a sample problem. A spring with a force constant of 5.2 Newton meters has a relaxed length of 2.45 meters. When a mass is attached to the end of a spring, it is allowed to come to a rest with a vertical length of 3.57 meters. What is the elastic potential energy stored in the spring? Well, the trick here is you have to find x. And in order to find x, you need to take 3.57, which is the number right here, and subtract it from 2.45. That will give you 1.12 meters. This is going to be your x value. Well, now that you have your x value, you can take that and have 5.2, which is your spring constant, which was mentioned up here, and you can multiply it by 1.12 squared. This should be a squared symbol, but PowerPoint sometimes messes that up. You take all that and you divide it by 2, and your answer is 3.3 joules. So that tells you how much energy is being stored in the spring. So here's what I want you guys to do today with the sub. I want you to log on to Edmodo, download the kinetic and potential energy worksheet, complete this worksheet, and as part of this worksheet, you also have to create a Venn diagram that has you compare all the different types of energy and to get an idea about what the differences between them are. There are directions for this Venn diagram on this worksheet, but think of it as two different activities today. When you're done, you want to turn this in on Edmodo. This is turned in individually, but you can work with your team and your partner, but you need to turn this work in individually. And if you finish before class is over, you are going to need to work on your homework. And you can find that on Edmodo as well. All right, guys, thanks for taking the time to watch this lesson. And if you have any questions, feel free to ask me when I get back, and I will see you all on Wednesday.